What's up, everyone? Welcome back. Patrick here. Moving on to the next question, another word problem dealing with factoring. So we're told the volume of a cylinder is given by this expression, 9 pi x cubed plus 24 pi x squared plus 16 pi x. And what we have to do, we have to find the radius, height, and surface area of the cylinder. So just as a quick review, remember a cylinder, if we draw just a general diagram here, if we have a cylinder, what is the general volume formula for a cylinder? Well, it's going to be pi radius squared times height, pi r squared h. Okay, and then the surface area formula is 2 pi r squared plus 2 pi rh. We're going to be using both of these formulas over here. Also, the surface area, if you don't want to, or another format, is you can actually notice factor a 2 pi r out, and you're left with r plus h in brackets. Okay, so this and this is the same thing. So you could use either of these formulas when we're going to be finding the surface area. So notice how we're given the volume of the cylinder. So if we write that, we got 9 pi x cubed plus 24 pi x squared plus 16 pi x. So we have the volume given by this expression, but notice if you have a look at this expression, it's not in this format. Notice that here we're adding a bunch of expressions, and over here in the volume format, we're multiplying expressions, right? We got a pi times an r squared times an h. And so it's hard to tell from here what the radius and the height is. And that's what we have to get in order to find the surface area. Because then once we have the radius and the height, we can just plug it into this formula. So what we want to try to do is take this and put it in this format where expressions are multiplying by each other, because then we could tell, or we'll be able to tell easier, what the radius and the height is. And so what we want to do with this is, you guessed it, we want to factor. So first thing we do, we look for our greatest common factor. Now between the 9, 24, 16, there's no factor from those numbers that we could take out. But notice that there's a pi that's common in all the expressions. There's also an x that is common in all the expressions. And if a variable is common, we always take out the lowest exponent, which in this case is going to be 1. So we can actually factor out a pi x from all of these expressions. And so what would we be left with in the brackets when we do that? Well, we would just divide all of these by what we took out, the pi x. So notice here the pi's would cancel out. We're left with 9x, and then 3 minus 1 would be 2. Here we'd have 24. The pi's cancel out. X to the 2 over x to the 1 is just x. Here the pi's cancel out, the x's cancel out, and we're left with a 16 like that. Right? So we're ending up with pi x times this over here. And then notice that this we can factor as well. So if we rewrite this over here, this is actually going to be a perfect square trinomial. So it's going to end up being a factor squared, and that makes sense because we have this radius squared. But it's perhaps tough to tell from here. Now, to recognize a perfect square trinomial, you can compare it to that formula. Okay, if this holds here, then we know that this is going to equal what? A plus B squared, right? And I put a positive here. There's also you could put a negative here and then a negative here, but because this is positive, we know that we're dealing with the positive case. So to recognize that, if your teacher is requiring you to use this formula, you can actually take this and rewrite it as 3x squared. I'm going to work with the ends first, because with the ends, Notice that's the a squared and the b squared, so we could tell that the a value in this case is 3x, the b value is 4. And then if we plug in those here into this middle term, we'd have plus 2 times the a value, which is 3x, times the b value, which is 4. And notice that 2 times 3x times 4 does indeed give us 24x. So because this format holds, where this a value is 3x, this b value is 4, it means that it's a perfect square trinomial, and it's going to factor to 3x plus 4 squared. A plus b, which is 3x and 4 respectively, you add those, and it's going to be squared. So that's one way to go about it. If your teacher is not using this formula, they're probably just going to want you to use decomposition, which, as I mentioned before, that's my preferred method. So if the a value is 9, the b value is 24, the c value is 16, we multiply the a and the c. 9 times 16 would give us 144. And then we got to find two numbers that multiply to 144 and add up to 24. Okay, in a perfect square trinomial, these numbers are always going to be the same. In this case, it's 12 and 12. 12 times 12 is 144. 12 plus 12 is 24. So then what we do is we take those two numbers and we decompose this middle term. We'll have 9x squared plus 12x plus 12x plus 16. Then we factor it by grouping. From these two, we could take out a 3x, so we'd be left with 3x plus 4. And from these two, we can take out a 4, and we're left with 3x plus 4. So as expected, that bracket's the same. And notice what we're left with, 3x plus 4. So notice we get the same bracket, which we can just rewrite as 3x plus 4 squared, like that. Okay, so multiple ways to factor this perfect square trinomial. So now going back to our main work here, this bracket, it factors into 3x plus 4 squared, like that. And now notice that we took this, put it in this format, right? This and this are the same. And now notice that this is in this volume format, pi r squared h. We can actually take this and rewrite it as pi. Notice that here we have something squared, so this would be like the r squared. And then we have the height over here, if we even put these in brackets just to really separate them, right? If we take this formula and put it right below, it's easy to see, look how perfectly it lines up, right? The pi's. And then, so we could tell what's the radius. It's 3x plus 4 in this case. So I'm actually going to write it on the side here. And then notice that the height is just this x value. Right? So that's actually part of the question that we solved. We found the radius, we found the height, and they are just expressions. So now what we can do is we can take those expressions for the radius and height and plug it into the surface area formula. Now again, you could use this formula or you could use this formula. I'm actually going to use this formula here just because I'm going to give you two different formats for the surface area expression, a factored format and then also an expanded format. And then over here, it's already nicely factored for us. But if you want, you could plug it in here as well. So if you use that first formula, you'd end up with 3x plus 4 squared, right? This r squared plus 2 pi 3x plus 4 times that h value. And then you could expand everything, and then from there you can factor. So that's one way to go about it. The way I'm going to go about it, I'm going to use that other formula because it's already factored here initially for us. So we'll just have 2 pi, the radius, which is 3x plus 4, right? This bracket is this bracket. And then we'll have the radius plus h. So we'll have 3x plus 4 plus the h value of x. So we'd end up with 2 pi 3x plus 4. And then over here, notice we got like terms. which is 4x plus 4. And then from here, we can actually factor further because this, from this bracket, notice we could take out a 4. So we can have 2 pi 3x plus 4. We could take out a 4 from these two, and we're just left with an x plus 1. And then the 4 and the 2 we can multiply. So we'll have 8 pi 3x plus 4x plus 1 like that. So this here is one format for the surface area. This is the factored format. So sometimes you may see this answer in the back of a textbook, but we can also expand this if we want. You may also see that answer. So let me just write out the factored form up here. And then if you want to expand it, you just have to multiply everything out. So you'll have, let's keep the 8 pi on the outside for now. We would just FOIL these out, right? Multiply all of these. So we'd have 3x squared plus 3x plus 4x plus 4. And then notice that the middle terms, those are like terms. So that would be 7x right there. And then we could take the 8 pi, we could distribute it in the bracket. So we'd have 24 pi x squared plus 56 pi x plus 32 pi, like that. So this format and that, they're actually the same expressions. This is the expanded expression, and then this here is the factored expression. So with a question like this, in a textbook, you might see this answer in the back, or you might see this answer. Or they might say, give both formats. Right? It didn't really specify here, so that's why I gave you both formats. Okay, so the biggest thing is taking this initial expression, factoring it, so it's in that volume formula format, so then you could get the radius and the height easily, and then you just plug it into the surface area formula and get your both respective formats.